Okay, let me show you how you can differentiate cotx and cosec x. How do we get this result in this table? In my previous video, you watch how I differentiated sine, tan, sec x, and we saw how we got this result. So let me show you how you can differentiate cot x to get this, and how you can differentiate cosec x to get this result. So if I start with cot, the same result, let's say you have y is equals to cot x. So don't forget the ratio. Cot x is the same thing as cos x divided by sine x. I've showed you before. Let me still show you the trig again. So you can see cot x is the same thing as 1 over tan x, which is the same thing as, you can see cot is the same thing as cos over sine. Very, very important. This is an important identities in trigonometry that you must not forget. They are very, very important. So if cot x is the same thing as cos over sine, then using our quotient rule, I won't waste time in this place. Remember your quotient rule. I used it in the previous video. Let me just bring it out. So this is a quotient rule. So this is quotient rule. Quotient rule says v du ds minus u times the v ds divided by v squared, and u is the numerator, then v is the denominator. So let's move on. If I use quotient rule to differentiate this, which is this, so my result is going to be dy dx. dy dx is going to be equals to, so dy dx is going to be equals to what? So v is the denominator, which is sine x, that is sine x, multiplied by differentiation of numerator now, which is minus, I'm going to have minus sine x, you know, we say v times du ds, and u is the numerator, so differentiation of numerator is minus sine x. See, it's multiplying the denominator, which is sine x, then minus u now is the numerator, which is cos x, multiplied by dv ds, which is differentiation of denominator, which is differentiation of sine, is going to give us cos x. So that is all with the numerator, then divided by v square, and v square is the denominator square, which is sine square x. So now that we have this, the next stage is going to be dy dx going to be equals to what now? Let's see. So dy dx will be what now? So this is minus, see, sine square s times cos square s. See, this is going to give us a negative result, which is minus sine square x. Then this is also minus cos x times cos s is going to give us cos square x, then everything divided by sine square x. You can see it. So that is that. Then the y dx will give us what now? So the y dx, so it's now it should be equals to what now? Let's see. So the numerator, so let's see, minus is common. Let's bring it out. Let's bring minus out. Open bracket, sine square x plus cos square x. Cos square x, then divided by the denominator, which is sine square x. Alright, so let's see at the end. Let me conclude it on this corner here. At the end, we see the numerator from our trig ratio, sine square s plus cos square s is equals to 1. This is that. Let me show you the identity, which is this. Sine square x plus cos square x is equals to 1. So when I substitute that in the numerator, what am I going to have? I'm going to have dy dx. So dy dx will be equals to what? Will be equals to minus 1 divided by sine square x. Sine square x. And that is that. Then how are we going to do this now? Let me see. How are we going to do this now? So we have, from our ratio now, let's go to our trig ratio. From our trig ratio, we said 1 divided by sine, you can see it. 1 divided by sine is the same thing as cosec x. 1 divided by sine is the same thing as cosec. So finally, dy dx is going to be equals to minus cosec. Since it's having square, you need to put square. Cosec square x. So that is the result of cot x. So whenever you differentiate cot x, it's going to give you minus cosec square x. And if you go through that table we summarize, I think you can see it. Cot x, you can see it is giving us minus cosec square x. You can see the answer is gotten without stress. So take note of that. The final one we have is this, which is a cosec x. Let me differentiate that and we move on.